David Madeira with Hemp Technologies. This is our first house in the United States. It's permitted. What you've just seen is the mixture. The mixture is the most important thing. That must remain consistent. As you can see from this wall, we're doing it in sections. Now these sections have to fit together, and that consistency of the mix is crucial. Now we did these on last week. We can take down the forms now and move them up. This is a big window here. We'll lay the bottom plate in it, and then this will be protected. So what we're using here is recycled plastic in reusable plastic shutter forms that lock together tight. Sometimes we have to screw them directly into the framing, but pretty much they'll unlock, and then we use them on the outside. Now this bottom layer, we need to leave that shuttering on for 24 hours. And after 24 hours, we can remove that first layer of shuttering system. And then we take the bottom shutters and we move them up on top. Now, in the perfect world, we'd have enough shutters to do both sides. But right now we have to keep reusing them to go around the house. So with these forms, with regular concrete, you have a slumping that causes the bottom form to go out. With Hempcrete, you do not have any of this slumping, so you don't have to worry about taking the form off too early. And with concrete, what would happen is pushing the form out. And that's why your forms have to be a lot stronger. And in this case, because we don't have any slump, we don't have to worry about that. Okay, so what we have here is the hemp shiv, or also called the hurd, which is the internal part of the stem of the plant. And that's mixed with a lime-based binder. And so with that lime-based binder and the hemp, we've got a negative carbon footprint. Now the difference between lime and concrete is that lime you don't have to heat up as much. Concrete you have to heat up to almost 3,000 degrees, which takes a lot of energy and does very poorly on the carbon footprint, whereas lime does much, much better. Now this binder, using the lime and the hempcrete together, you have a breathable wall, but yet air doesn't pass through, so you have a much more thermodynamic situation. One of the major differences between this and straw bale is when straw bale gets wet, it doesn't do as well as this. When this gets wet, it just dries itself out naturally because of its breathing capability. And so you never have mold, you never have dry rot, and you never have termites. And so this whole wall is going to breathe. So the cellulose properties of hemp are so much better than straw. Now there might be some plant out there that's even better, but we don't know about it. Basically what this does is, because of the lime-based binder, not only does it have a carbon negative footprint, it will pull carbon dioxide out of the air after the house is built, because the lime is trying to go back to being a rock, and it needs carbon dioxide to do that. That means this wall is going to get harder and harder and harder. Over time, it's going to petrify. So these walls will last for thousands of years, not 40 years like what we're used to building. So here you can see how well in the winter conditions the hempcrete has held up. We've had freezing down to 8 degrees Fahrenheit here, back up to 32, back down. It's gotten to 40 degrees, and it's done extremely well in this weather. So once it warms up, we'll put the finishing render on it. Wow. Neato. Neato.
It should have mud ring on there. If you guys skim coat over, it should have mud ring. That's not a problem.
Yeah, the whole thing, yeah.
Because it has some, we're not going to bring.
It has some structural integrity too. It's a non-structural material. So it's actually encasing the frame.
This just switch.
So,
How about the?
And then Madison's not bad, you know, but they haven't given us anything other than that glove factory you guys are talking about.
Wow.
And that's a sweet building.